Hello students, this is Mr. Allen, and today we're going to look at section 7.5, which is on proportions in triangles. Our objective today is for students to use the side splitter theorem to solve problems, and also to use the triangle angle bisector theorem to solve problems. Theorem 7.4, also known as the side splitter theorem, states if a line is parallel to one side of a triangle and intersects the other two sides, then it divides the sides proportionally. Now, please note that this is similar to what we learned with mid-segments, but these do not have to be mid-segments. So if you look carefully in this particular example here, you'll notice that this length here, this length RQ, is not the exact same length as RS. So this is a little bit different than our mid-segment theorem. And here's what the theorem says. If this side, or if this segment RS is parallel to that side XY, then what we end up doing is we get proportional lengths on the breaking points of the other two sides of the triangle. In other words, R or XR is to RQ as SY is to SQ. So let's see an example of that. It says, what is the value of X in the diagram at the right? Now note, this KL is clearly not a mid-segment, but note that KL is parallel to PN. So what that tells us then is that PK is to KM as LN is to ML. In other words, now we can convert that into the following. X plus 1, that's the length of PK, is to 12 as LN, which is X, is to 9. So now at this point, what we would want to do is cross multiply. Now I'm going to go ahead and put a couple of steps together here. I've got to do 9 times X plus 1, which is going to be 9x plus 9. Now notice I didn't write 9x plus 1. I used the distributive property to distribute that 9 to both terms. And then I got to do 12 times x, which is 12x. Now I can subtract 9x on both sides, which is going to give me 3x is equal to 9. And so we'll be able to get our final answer here. X has to be equal to 3. And we can check that. If you put 3 in for PK, then you're going to get a length of 4. If you put 3 in for LN, then of course it's just 3. So what I'm telling you is if we go back to our original proportion, I'll do this in purple, you're saying essentially 4 is to 12 as 3 is to 9. And I hope by just looking at those numbers substituted in, you can tell that that proportion is true. Okay, so now we're going to look at something called a corollary of the side splitter theorem. And a corollary is just a kind of a simple result from a theorem. So this is essentially the same thing as the last theorem. But notice here we're not dealing with a triangle. And it says if 3 parallel lines intersect 2 transversals. So you'll notice that we have line A, B, and C are all parallel. And then we have these 2 kind of vertical transversals. Again, we're going to get proportional lengths. In other words, this length here of AB is going to be proportional, or that ratio from AB to BC is going to be equal to the ratio of WX to XY. Again, let's just go ahead and look at an example of this. It says 3 campsites are shown in the diagram. What is the length of the side A along the river? So in other words, we're trying to find this length right here. What's that length? So what we're going to need to do is we want to set up a proportion. And in this case, I'm just going to call this side here X. And I'm going to say that X is to 8. So I'm going from this side of the river for side A to side B is going to be equal to 9 is to and then 7.2. Now, this is one way to do this problem, but what I'm trying to get here is I'm trying to figure out what this length is here. So I'm saying that x is to 8, here's the 8, as 9 is to 7.2. Now, I'm just telling you that another proportion that we could have used, in fact, I'll do it up here, that would also work is I could have said that x is to 9 as 8 is to 7.2. We'll check that in a minute, but let's go ahead and go back to our original problem. Let's solve this. Again, guys, like I've been telling you, a calculator is completely legal. I'm going to use one here in just a second to make sure I don't make any careless mistakes, even though I think this one works out pretty well. I'm going to do 8 times 9. That's going to give me 72. Okay, I don't need a calculator for this, but I'm going to pretend that I'm using my calculator. So now what I need to do is divide 72 by 7.2, and x is going to be equal to 10. So our final answer here is that length is 10 yards. That length we were looking for is 10 yards. Now, I'd like to go back to this problem I mentioned up here, this different way of thinking about it. Notice that work looks a little different than what we did here, but the answer will turn out to be the same. As soon as you cross multiply, you're going to get 72 equals 7.2x. So either way works. All right, so we got our third and final theorem here. Theorem 7.5, this is the triangle angle bisector theorem. And it says if a ray bisects an angle of a triangle, then it divides the opposite sides into two segments that are proportional to the other two sides of the triangle. Okay, that's a mouthful. So let me make sure that we understand. Remember, we're doing this whole if-then stuff, right? So first things first, we're saying that if this ray bisects that angle, in other words, those two angles are congruent, then it's telling us, I'm going to write this down here, that CD, that's this side, CD, is to BD, or DB, as, and I'm going to do it in green, CA is to BA. Okay? So I'm going to put in some numbers here. Actually, I'm not. I don't want to screw this up and then make more confusion. So if this ray AD is an angle bisector, in other words, it divides angle CAB into two congruent angles, then what it does is it divides that opposite side and then the adjacent sides proportionally. I think probably the best way to do this one again is to just look at an example. Okay. So here we've got a triangle, and it is, you'll notice that there is an angle bisector. So you'll notice that, and let me write this down, ray cubes, I just wrote that wrong, it should be ray QP, not QR. Ray QP bisects angle RPS. And remember, that's what we need. That's the condition that we need for our theorem. So we can see that. So now here's what it's telling us. Okay, and I'm going to come back to this. Since AD bisected that angle, we said that, and now we're looking at this. CD is to DB as CA is to BA. Okay, so what I'm saying is now I'm going to conclude that RQ is to QS, sorry about my handwriting, as RP is to SP. This is the conclusion. Okay. Now we can just substitute in. I'll go to a different color. So RQ is 10. QS is 18. RP is 12. And SP is X. So now we're going to cross multiply. Now I am going to use a calculator on this one because I'm not really sure I know what 18 times 12 is off the top of my head. I'm going to go ahead and cross multiply here, and I'm going to get 10x equals 216. And now we need to divide both sides by 10, and you'll get 21.6. So x in this example is 21.6. Now, guys, that decimal point's important. All the answers don't have to be whole numbers, so that's actually why I did this one. Okay. Now, Before I move on to our final example, I would just like to say I'm going to go back a couple of slides. Remember here when I said this was the proportion I was going to use, but I said if someone else did the problem, they might use this one and they'd get the same answer? Would like you to think about, is there a different proportion that we could have used here to get the same answer? And the answer is yes. And I'd like you to think about what one of those potential proportions might be. All right, last but not least, I wanted to do an example here with a little bit harder algebra. And so here we go. Now I'm going to have to add a little bit to this. So what I've got to add to this is the following. Okay, and I didn't add this already. So I would like to go ahead and, for the sake of this problem, we're going to assume that those two angles are congruent. Okay, so we want to assume that angle BAD is congruent to angle CAD. All right, that makes ray AD. So this is going to make, I'll put an arrow, that's going to make ray AD an angle bisector. Okay, and remember, that's the requirement for this type of problem. So now we need to set up our proportion. I'm going to go ahead and do this in red. So that means that BD is to DC as AB is to AC. And now we can just go ahead and start substituting stuff in. Let's do that in blue. So what's BD's length? Well, that's x plus 2. DC's length, that's x minus 1. AB is x, and AC is x minus 2. Now this one's going to be a little bit harder because when we cross multiply, we're going to have to do a little bit of algebra. So we got to do x plus 2 times x minus 2 equals x times x minus 1. I'm cross multiplying. Now we've got a FOIL, so that's going to be x squared minus 4. And then this is going to be x squared minus x. Okay, I'm kind of running out of room here, so I'm going to go ahead and erase this work up here. So now we go up to the top. I'm going to subtract, actually this, I guess I didn't really need to. Once you subtract the x squared, this is actually pretty simple, isn't it? If you subtract x squared on both sides, you'll get negative 4 equals negative x. And so therefore that conclusion is that x has to be equal to 4. I guess I did need to erase all that stuff. And that kind of ends this particular video. So thank you.